Hi Dragons, so here's part 2 of the intro lecture. It'll probably take us this week and next week before we get through just the intro. There's a lot of concepts and terms to know, so let's just get right in there. So why should we do research anyway to begin with? Well, we're curious humans, and we want to know things. We want to be able to explain, to describe, to predict, right? We want to be able to understand what it is that's going on with the world, and we want to do it with some sort of accuracy. We don't want to just guess at it, so we have to have a systematic way of determining the truth so that we understand the world around us. So historically, as you can imagine, we don't have the scientific research that we have today, and not even the method or the ability. So we had a lot of different groups trying to figure things out all at once, and the ones that primarily got the most attention to begin with were the philosophers, of course. And you had Plato and Aristotle and all of those guys trying to figure out, the world, human behavior, medicine, all of those different sorts of things. So today we call the scientific method, and the way we understand research is through empiricism. And empiricism is the scientific method, the way we experience the world, okay? So an empirical study would be one that has been subject to the scientific method, and you have data that you have derived by a given scientific methodology, and then you analyze that data, and then you interpret that data to come up with a conclusion or a generalization for what you've done. So that is an empiricism, and the father of empiricism would be John Locke. And John Locke, he was the one that said, humans are a tabula rasa, or a blank slate, and life writes its experiences on it. So he was really the first proponent of you have to experience the world to find out what is true and what is not true, okay? Outside of that, we have introspection, and introspection is, I guess the closest thing you could call it today would be like meditation. How you turn inward to find the answers, and that usually follows a nativist sort of philosophy. And a nativist sort of philosophy is that all behavior, we are all born with the potential to understand and to know about the world, that we don't have to go out and experience it. So empiricism is just the opposite of that. You have to go out and experience the world to get to your truth. So nativism is much more subjective. It's what you experience. It's internal, and it's very much a personal, meditative, reflective kind of activity versus going out and manipulating data and see the world for itself. So this is, as you can imagine, nativism. Immanuel Kant, K-A-N-T, is the person who championed the cause of nativism, okay? So it falls in with religion and introspection, mysticism. If you look at some religious groups, they have what we call mystics. These are people who had, you may say, a personal relationship with God. They feel like they were divinely inspired. That sort of thing. But those things come by in terms of a faith versus go out and test what's happening in the world. The opposite of mysticism, which would be a faith, what you believe, what you've experienced on a spiritual plane, the opposite of that would be realism, that the only thing that is the truth is what's happening in front of you in reality. So we can get into the idea of what is reality. Why can't faith be reality? All of that sort of thing, too. Those are more philosophical arguments. So what you see here is a convergence of philosophy and religion and the emergence of empiricism, or what today is science. So at the heart of the scientific method is what we call contingency logic. And contingency logic is if X, then Y. You want to determine the relationships between two variables. That's contingency logic. So if it gets cold and the sky is going to open up, and if it's below 32 degrees, are we going to get water rain, or are we going to get snow or ice? So if this, then what? Okay, that's contingency logic. And so that is one of the first forays in the scientific method that we look at. If this, then what? Contingency logic. So the goals of science is to describe, to predict, to understand, to explain, all of those kinds of things. So today, there is science and there's non-science, okay? So you have to be able to distinguish what is real science and what is fake science, okay? So, and that brings us into pseudoscience, which has, in terms of the scientific method, we have a set of procedures, methodology, that are tried and true, that will bring answers from science. And pseudoscience is one that diverts from that, okay? So you can have faith, you can have belief, you can have opinions, you can have all of those things, but you have to be able to back it up with hard data. And the way you get hard data is to have a very meticulous methodology, okay? You may believe that, rubbing dirt in a wound will cure you of COVID, but you have to do experiments that will lend themselves to actual data, measurement of improvement, to show that, rubbing dirt does not cure COVID, okay? And then all of these things are grounded in what we're calling, so what do you call a cure? I often in the first day of class go, when you say you have a cure for cancer, what does that mean? What does a cure mean to you? And some students will say, well, a cure is that I don't have cancer anymore. Okay, so is the absence of cancer a cure? Is a cure the halting of a progression? Is a cure, I have been sick and now I'm going to go back to the way I was before cancer even showed up? See, there's a lot of different definitions of the thing that you're trying to measure. That's why in research you have to be very, very precise about what you mean when you define a term that you're going to measure. And you'll see that when you do your project, I'm going to make sure that you're very, very precise about what you're doing, because otherwise that will leave you open to criticism and maybe subvert all of your findings because you didn't define your variables properly, okay? So actually I had some students maybe 20 years ago, they decided to do belief in ghosts and the supernatural, which was a kind of an interesting experiment. But that generally those kinds of things are pseudoscience because they're very difficult to measure and they're subjected to a lot of interpretation that are not empirical. But you can make it empirical, but you just have to be very, very, very precise. So another thing that we look at when we talk about research is what is the paradigm that we're measuring? And a paradigm is a set of beliefs or a set of theories that we're testing. Okay, so the theories of how people learn, or the theory of how people develop mental illness, or the theory of immunology. Those are big, multi-theoretical things that all come together and form what we call a paradigm. Okay. So sometimes you have, that's my cat. My cat is going to come in here and try and get into the picture in a minute. Sometimes we have something that is measured by converging operations. So many times students are like, well, a lot of people are doing research in heart disease, let's say. And we don't have a cure for heart disease yet. Why don't we have a cure for heart disease? Because heart disease is complex. We're only finding out little bits and pieces because, remember I told you, research is very specific, okay? So sometimes in class I'll say, okay, let's give an example. And I go around the room and I ask people, are you in love? And some people say, yes, I'm in love, and I'll say, well, how do you know you're in love? And they'll tell me, if there's 20 people in the room, they're going to tell me 20 different things about what they think is love. Some people will say, well, I'm sexually attracted to this person. I'm like, how do you differentiate that by definition from lust? Is love lust? And that'll stop them in their tracks and they have to sit there and go, I don't know. So the same thing is true of heart disease. Well, what do you mean when you say heart disease? Do you mean high cholesterol? Do you mean heart attack? Do you mean plaque on your arteries? What is it that you mean? Because those are important, because that's what we have to measure. So when you sit there and you think of something like heart attacks or heart disease, what do you mean by that? Are you talking about cholesterol? Are you talking about a propensity for heart disease in your family? Have you already had a heart attack? All of those kinds of things is what I'm saying. So a convergence of operations is, here's the heart disease problem. And then Dr. So-and-so is studying how heart disease relates to cholesterol. Dr. So-and-so is looking at the genetic link between heart disease and heart attacks. Dr. So-and-so is looking at diet. Another doctor is looking at medications that someone is on. Another one is looking at high blood pressure. So you see what I mean? And we're looking at all of those little separate specific pieces and how they come together or converge on an issue or a subject matter, which in this case is heart disease, right? So converging operations oftentimes is what we are doing when we're tackling a big problem. Okay, so right now I'm doing research on COVID, and I have been doing it since, we've had this outbreak. And one of the things, I think I told you this, was last year at this time I was in Africa, and they were talking about testing. So the United States government came out and said, well, we're testing everyone at the airport, which I know wasn't true, because I went to 8 different airports internationally, and nobody was doing testing, what I would call testing. And what they called testing, some places, was, I'm going to take your temperature. They weren't doing like the nasal thing that tested for the presence or absence of the virus. Everybody had a different definition of testing. And I remember watching Dr. Ho, he was with the World Health Organization, and he said the only way we're going to get a grip on this is if everybody in every country does the same thing and calls that testing. And he is absolutely right. That would be converging operations. But we can't even do this. We can't even do that in the United States. We have 50 different states with 50 different ideas of how to tackle COVID. Okay, and so in the United States, we don't even have that unanimity, and you saw that that was getting really difficult. So when I started doing research, I had all these different research partners in all over the world, and guess what? They're all doing different things too. And for places that had different states, like Australia, they had different states too, and every state was doing a different thing. So you wonder how we haven't all died from COVID, because nobody is doing this, same sort of thing. Everybody's doing something very different, and now we have a mutation, and it's in some places and not others, in some states and not others, and that whole idea of converging operations is just going to hell in a handbasket, right? Because nobody is doing anything that is sort of unanimity. Everybody is doing pseudo things on unanimity, like we all have some lockdowns, but not everybody's doing the same thing. When they say lockdown, they don't all mean the same thing. When you say we have a mask mandate, well, some places are doing a mask mandate and some places aren't doing a mask mandate, and some people get away with it and some people don't. I was this summer I was in Michigan, and I was going into a store, and I forgot my mask, as we all do. And I was like, oh, gotta go back. So car next to me, they were watching me leave the car, try and go into the store, and then go back to get the mask. And the guy yells out the window and goes, you don't need the mask. They don't even check on that. I'm sitting there thinking, well, there's your, it's not really a mask mandate then. And it's, in Ohio, you could get a big fine. In New York, you could get a big fine. In Canada, you'd get a really big fine. So we're not all doing the same thing. So there's where research comes, in terms of converging operations and the specificity of research, how we all have to sort of do the same thing to get the same result. So when you are confused by research, it's not you. It's the normal process of lack of uniformity. And so this is why when we do research, we're going to make sure that we all are uniform. So I'm going to stop here and then pick up with part 3. So see you in a minute.